Hello, and welcome back to Manufacturing Tomorrow's Workforce. I'm Amanda Del Buno. A quick note before we get started with today's episode. This podcast was recorded before the coronavirus pandemic. Thus, there are points within this episode which may not accurately represent the current job market and in-person training opportunities. Additionally, the pandemic did result in some scheduling changes for Manufacturing Tomorrow's Workforce, so this episode was not able to run when it was originally scheduled to. With that said, in today's episode, I'm joined by Plant Services Editor-in-Chief Tom Wilk to speak with Deanstedman, CNC Education Program Manager for FANUC. Stedman shares how the company built a CNC training program with high schools and colleges around the United States that helps manufacturers to more easily find the trained CNC machinists that they need. Here's the interview. Today, Tom Wilk and I are joined by Deanstedman, CNC Education Program Manager for FANUC. FANUC's CNC Certified Education Program is centered on core processes, principles, and interaction with real industrial equipment by providing equipment to partnering schools and universities. The program partners with more than 600 community colleges and high schools to train students on CNC simulators and other industrial equipment. Thanks for joining us today, Dean.
Thank you.
So, let's just get started. Can you kind of just tell me what the story is behind your CNC program? Why was it important to your company to get involved in education in the first place?
Absolutely. So FANUC is a large industrial supplier of CNC controls to other machine tool builders. We have a large install base out there, and we were getting feedback from some of our large industry customers, the end users, that they were struggling to find people with adequate skills in CNC programming and machine operation and things like that. So we really listened to that feedback that we were getting and decided to put a program in place. And this all started about 6 or 7 years ago.
Oh, wow. And how has the program grown in that 6 or 7 years? I mean, what was it to begin with?
So before we had no program, we were, like I said, a manufacturer of equipment, but we didn't interact with schools or anything like that. We didn't have curriculum for students. We didn't really have training-specific equipment either. Everything was very industrial. So we worked with our parent company in Japan to develop simulators. We worked with an outside company to actually provide and develop curriculum for the students to use, and then training courses as well for the instructors to come to FANUC to learn as well.
Oh, wow. So there's a lot going into just
putting it together. There's a lot of moving pieces, and it's an evolution as well. Manufacturing doesn't stand still, so we're always looking at what can we do next and trying to collaborate with the schools and collaborate with other industry companies to bring all of this together. So it's not just CNC, it's CNC and robotics and PLCs and data collection and those types of things.
Mm-hmm. So what are some of your goals with the program? What are you hoping that your students take away from it at these partnering universities?
So really what we want students to take away from it is an understanding of programming and operation of CNC machines to gain more knowledge in the manufacturing process, to really dispel the myth that manufacturing isn't a great industry to be in, because it's complete opposite these days, where the industry is very high tech, it's very fast moving, it's actually very cool. But the students don't really realize that, I don't think, going into it. Most of the time when we talk to students about what do they know about manufacturing, they learn this from a history class or something, and their images of that early 1900s Ford assembly line, where everything's the 3Ds, the dirty, dark, and dangerous industry. Whereas the reality is it's much cooler, it's high tech, and there's high value equipment being used. So we want them to be competent in using that equipment, but not just using it, because the technology is moving along fast. We want them to use it in the correct way as well. So it's an evolution. So how we program and operate machines today is different to what it was 15, 20 years ago. So it's really upskilling them, making them aware of what's out there, and really making them job ready.
Right. Interesting that you say that changing perception is something we've talked about a lot, is getting people to see manufacturing as an industry they want to be in. And with young people, I think that hands-on experience is really a game changer. Yeah. Is that something you guys have noticed?
Yeah, and there's plenty of young people out there that are into making things. They like to work with their hands. They may not necessarily be the types of students that want to be a doctor or a lawyer or something like that. They want to actually make things. So they're already that way inclined, and we're just trying to open their eyes to the possibilities of it actually being a real career as well.
Mm-hmm.
But we do pull in other students that maybe didn't look at it at all from, say, computer science and things. They're looking at it as well now because, there is a big demand for the digital side of things, for the data collection and the analytics as well.
We see that so often in maintenance reliability where anymore there are apprenticeships that exist to bring new workers into the field, but that's not the primary stream of new workers anymore. It's one of multiple streams, right? Mm-hmm. And we find that we're getting people in there who either trained in mechatronics, trained in control system design, CNC, robotics, and then they realize that this might be one smaller piece of the larger puzzle. And it sounds like that's what you're seeing too, students moving in from different directions.
Yeah, and so we're just one piece of the puzzle as well. We try and work with other industry companies. We try and keep a handle on what's actually going on in industry, what type of equipment and processes they're using to try and relay that back to the schools. Primarily, we target high school and community college for associate's degrees and things, so we can add our content and our equipment and services to programs that already exist for engineering or for mold making and things like that, different courses that they already run. Mm-hmm. But we do try and reach a bit further down to middle school I think you've got to sort of capture their imagination when they're a bit younger. We're not per se going to be trying to teach them anything at that point. We're just showing them, the types of industries that are out there and how cool it can be. Beyond community college, we do a little bit with some universities, but they're not really interested in the actual operation and learning how to use a CNC machine, but they will use the equipment for research purposes. And then outside of the sort of the generic academia stuff, we do work with veteran retraining groups, incumbent workers, and inmates as well.
Oh, wow.
Okay.
Yeah. So there's a few programs that we'll work with prison services as well.
We just did a cover story about Chicago opportunities of that kind. Both inmates moving back into the workforce as well as veteran groups. Mm-hmm. And there's just such an untapped stream of people to actually move into industry and take charge. Yeah. It
provides a very good living wage. The salaries are very good right now. There's a lot of benefits to being in manufacturing, and there's a sense of satisfaction for a lot of these people as well that they're actually creating, they're making something as well.
Yeah. I'm struck at how Chicago itself has been a hub of this too. Have you noticed that being based in Hoffman Estates here?
Hoffman Estates, really between O'Hare and Elgin, we call it the Golden Corridor. So that there's a lot of machine tool builders. And then the rest of the supply chain, so the tooling companies, the CAD-CAM companies, coolant companies, the actual builders themselves, the control manufacturers, and EDM, punch press, laser, we all seem to congregate in this area. We tend to say they cluster because we've got a lot of regional offices around the country, and we're usually neighbours with one of our big customers as a machine tool builder or something like that.
Yeah, and I think it's interesting. Like, to me, I always think about kids who know that they like to build things that they don't know what to do with it. Mm-hmm. So you guys kind of touched on the perception. How would you say that the program has been successful in changing the perception? Do folks notice students leaving with a different view of the industry, and how do you try to show them that different? Yeah,
definitely. We will host tours at our facility. We do trade shows where students are invited. IMTS is a large one that happens in September this year. So there'll be a student summit there. And in the past, there's been, I think, around 25,000 students have attended. So we take all the latest and greatest. We try and take all the cool gadgets and stuff like that. And we're showing them this equipment being used. And just for them to watch, for example, a robot moving around and using vision to identify different things and pick them up and move them, you see the fascination. You see them look at it and go, wow, that's something I want to do. And so just changing that perception and making it look cool for them is definitely something we see as a game changer.
Mm-hmm. Mm-hmm. And you see kids leaving, or do you know if any of these students are moving on to get careers in the industry? Do you hire out of it or anything like that?
We don't hire directly, not very often anyway. Sometimes on the robot side we may take an internship and that'll develop into an actual job. But we, as a company, we don't really program our own controls that often, but we have such a large install base out there that there's plenty of customers already using our product that are looking for these people to recruit them. So that's primarily where students that have gone through a program that had some of our content in there, they will then go to an automotive or an aerospace company or something like that and start off as maybe a machine tool operator, maybe a programmer, but then eventually they'll work their way through into other positions as well. With 5 or 10 years of tenure, they may become an engineering manager or something like that as well. So we see that being a career pathway once they get in the door. And so this was the whole reason we started the program. These manufacturing companies said they needed new hires, and they needed people with FANUC experience. So
what kind of feedback are you getting from your partners, those manufacturers that you work with, who are taking in your students? What are they saying as far as
So I think for the most part, a lot of them are still struggling to find people. There's only so much we can do as one company. It is a collective effort. But in certain areas where we've been very active in states like Ohio, we have a lot of large automotive companies like Honda there that have seen a big influx. I mean, we're looking at almost 100% job placement for people coming out the course. So it's made a great impact in those areas, but it's still just, what we can do is still a very small part for the overall picture.
Right.
Ohio is a fascinating case, too. I worked out there from 1992 until 2006 and witnessed firsthand all the jobs moving out of that state. It's interesting to see, number one, that they're sort of bouncing back in now and reemerging. And number two, Columbus, which was where I worked, now they've got a 3D printing center as part of the Ohio State University. They have the FANUC courses and the FANUC involvement in industry. Mm-hmm. It's good to see that traditional manufacturing base sort of reemerge because, a lot of times this kind of labor can be generational. Sons and daughters want to go into what their mothers and fathers went into. And it's nice to see that the space seems to be coming back.
Yeah, I think for certain states like Ohio, they were facing a job shortage or a skill shortage issue with the baby boomers retiring. Mm-hmm. They had an older generation working at the time that were leaving the workforce, and they didn't address the issue. So the state actually got involved in that state to actually do a lot of the funding as well, because some of these large companies were looking to move to a different state where there was an abundant workforce. So it was an issue for the state. On a state level, it was a problem. They were going to have to do something to try and keep these large companies there.
Right. I'm curious to know, have you seen impact from the Perkins Act reauthorization come through? That was something where one of the advocacy groups visiting Capitol Hill was the SMRP, Society for Maintenance Reliability Professionals. They do a fly-in every year to talk to congressional leaders. And specifically, they had spoken to an Illinois representative, Raj Krishnamurthy, who was one of the bill sponsors. And everyone was excited when the bill finally passed.
Yeah. The Perkins grant is one of the main ways that a lot of schools throughout the whole country actually get a lot of their funding to purchase capital equipment. Mm-hmm. And obviously, the equipment is not always very cheap. Now, we try not to profit from anything that we do. We do most of it more or less at cost, but still, a CNC machine can be quite expensive, so they have to apply for funding. Sometimes that's philanthropic. There'll be a donor that maybe will sponsor or help out there. Sometimes it's state level, and sometimes it's federal money as well. But Perkins is a grant that's been around for quite a few years now that a lot of schools tap into when they try to acquire new equipment.
I'm curious, which states or regions in the U.S. have embraced your program? We talked about Ohio and Illinois. Are there other areas regionally?
So our install base across the country is quite diverse. There's certain states where it's more agriculture and not so much manufacturing, but where we see the most activity as far as schools go tends to follow the install base as well. Okay. So it's mostly around the automotive sector. So we really can talk about the Rust Belt, Wisconsin, Illinois, Indiana, Michigan, Ohio, but also down in the South as well, where we have a lot of foreign automotive and aerospace as well. So states like Alabama and Georgia and the Carolinas are very popular. Texas is very big as well. We have a lot of schools using the program in Texas and over on the West Coast in California and Washington, places like that as well. So,
all right.
Yeah. So it's nationwide, including Alaska and Hawaii, but we just actually sold a piece of equipment to Hawaii, and I need to go over there check it out.
Hard work.
Yeah. Let me know if you need help.
Have someone else haul it up the volcano.
Yeah.
You get together.
So what do these programs typically look like? What is it when, let's say, a school wants to get involved? What do they have to do? How do you get this started? And then what are students experiencing? What does a typical class day look like?
Yeah, so we start off with basic CNC milling and turning. So it's 2-axis turning, 3-axis milling. We will teach the instructor, so we will take the instructor to a FANUC facility. There is some online training they can do, but we always advise that they come to a FANUC facility where we have training classes. And we will give them some lab time using simulators. We'll go through the different types of G-code and the navigation of the control, and they end up actually running a machine as well. Now, for some of the instructors, they've already been in industry, so they know CNC already, but maybe it's been a few years, or maybe they're not as familiar with FANUC, so it's more of a refresher. But some of them have never touched CNC before. They were the woodworking teacher before, and now they've been told they need to run the CNC program. So the instructor training is key to our program. We need to make sure that they're competent in what they're teaching. The next part is the curriculum for the students. So we have an official provider of that curriculum, and we have a lot of input in the creation of that curriculum. But again, it's either lathe, 2-axis lathe, or 3-axis milling. And then they need equipment to practice on. So we work with a lot of machine tool builders. Particularly, we work with a machine tool builder that makes a single phase, 110 volt on wheels machine that they can wheel into any classroom. And that's the main one that we would use really in high schools. So once they've got that, they still need some type of simulation, because you're not going to go straight from a textbook onto a machine. So the simulation allows you to get familiar with using the control, gets familiar with actual programming. We can verify the programs will run and check everything out and make sure everything works fine. We have some other simulation that plugs in on a PC-based software. We'll actually emulate the machine moving in real time as well, so we can detect if there's going to be any crashes or collision, breaking tools and things like that. So that can really get them competent and also confident in what they're doing before they go out onto the machine. Because if you crash the machine, unfortunately, that can be expensive for the repair. Plus, you've got tooling costs, and you've got like the coolant and the material and things like that. So there's an ongoing cost to the machine. But we always say that in order to get through the class, at some point you've got to cut metal. So really, it's based around a few different things: instructor training, curriculum, some form of simulation, and then actually running a machine as well. So those four pieces. Beyond the basic 3-axis milling and 2-axis turning, we do encourage them, and we do help out with equipment for 4- and 5-axis machining. But at that point, we're not really G-code programming. Our emphasis is on learning the actual G-code and programming longhand. But once they get to 4 or 5 axis, they're going to be using some type of CAD-CAM system anyway to post the programs for them. But they still need that fundamental foundation knowledge of the machine tool itself, so they would get that at the 3-axis milling level. And then there's other industries as well. There's other machine types. So we see some can go into wood routing, or sometimes we get involved with a tool making class or something that maybe has wire erosion, like an EDM machine. So there's a few little spin-offs from it, but the core is 2-axis turning, 3-axis milling, and we provide everything they need to get going with that class, including coming into the class sometimes just as an aid or as just like a guest speaker. Sometimes we'll do that as well with some of the schools.
Well, I understand that you also have the robotics program. Can you tell us a little bit about that?
Yeah, absolutely. Our robot program actually started a year or two before our CNC program. And the thing with the robots is that we make the entire product. So we have to teach people how to use the entire product. With the CNC, we build the control. So we build all the software and the HMI is all done by FANUC, and all the hardware for the controller. But the machine itself is usually built by someone else. But the robot is all us, so we have to teach how to use the robot. And all the training classes that we have are aimed towards industry, and we replicate and use those same classes to train the instructors. And also on the robot side, that same curriculum that we teach industry with is the same curriculum that will get used for a student in a high school or community college. So their programs, they started a little bit before us, and we sort of try to really replicate that. So again, it's instructor training, it's some form of simulation, it's the real robot in the classroom, it's the student curriculum, and they go through the whole training program. For both CNC and for robotics, it's usually about 40 hours of student curriculum, plus extra time for hands-on and doing more exercises in the lab. Additionally, on the robot side, a lot of robots have vision, so there's a separate curriculum and training course for the vision side. And now we're also seeing more collaborative robots, so there's some more add-ons for the collaborative side of things as well. So that's really what they do on the robot side of things as well. Now, with CNC, there was already a nationally recognized credential, and that's called NIMS. So we really push people to go down the NIMS route when it comes to actually getting a certification. We'll issue a certificate to the school to give to the student, which will have FANUC's name and logo, which we've been told by employers really does increase their prospects of actually getting employment, because if they're using only FANUC in the machine shop, someone comes along with a FANUC certificate, they're going to probably get bumped up the list of resumes. But for the robot side, there was no nationally recognized credential, so we created one with a company called Nocti that underwrites the exam.
Okay.
So then are those certifications that the students should be able to test for and acquire after they finish your programs?
Yeah, after they finish and while they're actually training as well. So once we class a school as FANUC certified, i.e. they've met our criteria of instructor training, use the curriculum, have the equipment on board, we classify them as FANUC certified, and then they'll get our certificate on completion anyway. For the Nocti one, they will have to take an exam at the end of that. And for NIMS as well, because it's an independent organization, they would have to take the NIMS exam, and that usually involves making a test piece that needs to be then sent off for verification as well.
You know, and you mentioned IMTS before on the
Yeah.
CNC side. Do you have a similar partnership with an organization like A3, who does their show every other year as well? We've spoken with them, but the Association for Advanced Automation, and it's a robot. A lot of what they do is robotics related.
Okay.
Maybe a better question is what kind of robotics trade shows does FANUC associate with to help get the word out about the robotics program?
We do a lot of education-specific shows, but we'll talk about the program. So we are a member of the American Association of Community Colleges. Okay. And they have an annual show. It'll be next month, actually. I shouldn't say next month because this doesn't go out till July. That will happen in the AACC show happens in March. Okay. I believe this year. There is another one called the ACTE, which is the Association of Career and Technical Education, which we're a member of as well. Okay. And they have an annual show, which we go to. They also have a lot of shows at state level. So there'll be lots of them going on throughout the whole year, but they have a bigger show at the end of the year, usually late November, early December, that we will attend. And we'll take some of our classroom equipment, and we'll take some of the people that are involved in the program, and we meet with a lot of the instructors. We meet with the principals. We meet with the people that control the money sometimes, and sometimes the students come along as well. But yeah, so we're members of AMT. We actually have one of our members of staff on the board of AMT. We also members of SME, and they host or co-host a lot of trade shows throughout the country. East Tech, West Tech, South Tech, Hughes Techs, Aerodef, these types of shows. Most of these, and these are aimed at industry, but most of these, if AMT and SME are involved, will have what they call a student summit. So they will invite local students and they will bus them in some cases. So we sometimes have an additional booth there where we will set up. In addition to that, we work with a lot of the other organizations like NTMA and companies like that as well, where they have an education outreach program, and we try and involve with those as well. So we network with a lot of people. The circles run quite tight with the education world. So.
Okay. Yeah, I had a question about associated technical areas, and by that I mean some of the trade shows that Plant Services appears at are PTC LiveWorks in Boston every year, the OSI Soft Pi World event in San Francisco. And one of the trends that we're seeing is that people who move into this field, again, as you know too, they come in from different fields. They learn what they learn, they choose to stay, or they might move on eventually. Do you see students discovering the CNC program in related fields as they come in through, say, PTC ThingWorks coding or OSI Soft sort of database management and advanced analytics?
We've seen a few that have crossed over and jumped over into CNC. Some examples that I can think of have been automotive repair, and things like that, where they're actually already taking a class in automotive repair, and then they see the CNC machine shop and get curious and investigate that, and they've jumped into it. We've also seen with computer science and things when they're doing data analytics, and then they've started to look into the manufacturing space as well to see if there's stuff that they can apply their knowledge to there. And that, like I said earlier, that's a big thing right now when it comes to IoT, the industrial internet, where we're actually connecting to machine tools and we're pulling data out. We're running analytic algorithms through that data to try and improve the efficiency of machine tools and the actual whole process to improve the efficiency and effectiveness of that. So that's a big area for FANUC and for anyone else in this industry right now is the IoT side of things.
Right. It's funny, the workers in this industry have such a wide range of interests when they move both professional and personal. My favorite story was a woman who had worked for NASA for a long time, who eventually opened up a digital winery because she wanted to apply these industrial analytics to the wine production. And number one, it was one of the most California things I've ever heard. Number two, she had tired of aerospace and she wanted to apply what she knew to an entirely different area of interest. And she chose one of her hobbies. And now she's got a digital winery in Napa Valley.
Oh, very cool.
People who are in the maker movement, it would seem, would also be good candidates for this kind of program. Have you seen interest from maker associations when you promote your program?
Yeah, we work with some schools that have a maker space or a fab lab or something like that in there. And typically they're looking more at the 3D printing side of things or wood-related products as well. We see sometimes little small desktop wood routers. But they're still inclined they want to make things. There's in the name, maker space. But when they see the CNC side of it, yes, they do get interested. And some of the tabletop machines that I mentioned before have found their way into maker spaces as well. So they're not teaching CNC machining per se. They're not trying to build a machine tool operator or a programmer, but they're using that equipment and gaining knowledge of using that equipment in the bigger picture of their maker space of what they're trying to do there.
Yeah, I've found that the really skilled 3D printer researchers have a strong appreciation for CNC because the tools are very specific in what they can do and what you can't do. My favorite quote was from that Ohio State lab, and one of them said, if you can CNC it, then for Pete's sake, just go ahead and CNC it. Yeah. Because that's the best application of technology for what you're trying to do. Yeah. Don't try and 3D print something like that. So it seems like those technologies are more complementary than some might think.
Absolutely. We get a lot of students that would maybe come up to a trade show booth and see a CNC machine and ask us, is that a 3D printer? So we then try and explain to them the difference between subtractive and additive manufacturing. And both, there's pros and cons to both and where one may be better suited than the other. Typically, we see it as a complementary technology, and I don't think CNC is ever going to go away.
Agreed.
It's really the workhorse of manufacturing, but if you can understand the concepts of a 3D printer, to transfer that knowledge to CNC is really not that difficult. I mean, essentially they're going to run on G-code, and essentially they're working on a coordinate system from the programming standpoint. But the CNC is removing the material, and the 3D printer is laying it down in a sort of slice format anyway. Yeah. The distinct advantages that we see are really in the aerospace when you would make multiple parts to finally assemble, where you could 3D print that maybe in one part. Right. The CNC is very, very fast and can offer a much better surface finish technology. But the drawback to CNC is the tools can only go in a straight line. The 3D printer can go around corners inside because it's built up that way. So,
right. Yeah. Well, and CNC has that legacy within manufacturing as you mentioned, the go-to technology for manufacturing certain parts. Yeah. And so once you mesh that technology, you do have an understanding of the way the industry has evolved. And it's such a great base to move on to things like 3D printing or any other technologies.
It's a good point you mentioned there as well, because we see a lot of these machine shops in classrooms in the schools where they've still got the old manual equipment. And we absolutely agree that there's still a place for that, because when it comes to understanding the materials and the tooling and the feeds and speeds and X, Y, and Z is still the same axes on a manual mill as it is on a CNC. But if you can do that on a basic level on a manual machine first to gain a foundation knowledge, and then jump onto a CNC, we see the pickup and transition into CNC being much faster because they already understand the basics.
For some reason, the metaphor of someone playing football at the college or high school level and then moving to the NFL came to mind, where maybe they've worked on the manual CNC machines, but then they come to your program. Do you get a response like that from students who are like, oh, holy cow, the game has changed, and it's, as you said, it's a lot faster than it used to be, and here's what's happening in technology, in industry?
Yeah, I think we don't really see it going that way. We see them come in really aimed at the CNC first,
okay,
and then they get pushed through maybe the manual machine route, and they maybe find that a little bit boring at the beginning to understand that. They're not usually coming in to start on manual and then they see the CNCs. They normally come in with the intention of doing CNC, but we don't force them. But a lot of schools will still have them run through some manual equipment first and then get onto the CNC. But
well, is there anything else that you'd like to add, or you think we should know about the programs?
I think, there's more information if people wanted to come and look at FANUC's website, which is fanucamerica.com/cert, which is just an abbreviation for Certified Education Training. I would say that really what FANUC's doing is not in complete isolation. There are a lot of companies out there that are doing similar things with regards to creating their own programs. We're not the only one. We try to work with a lot of different companies in mechatronics, so networking our CNC machines and robots to PLC so they can do process control, data collection, CAD/CAM, tooling companies. We're all working together. We've all got the same goal, the outcome. We want to increase the size of the knowledge base for manufacturing engineers coming out. We'll all feel the effects of a rising tide if we all play our parts. I think it's very important for society in general that large OEM type companies get involved with their local schools, get employees on the advisory boards, advise them what they need to be doing, help out with funding where they can, and certainly be involved just as a source of knowledge as well.
Mm-hmm.
That's what we've seen too. Even if people have opinions on whether it's one group's main responsibility, industry, government, to drive this, it's everyone's responsibility. Mm-hmm. Rising tide raises everybody up, as you said.
Yeah. Well, great. Well, thank you so much. We appreciate you coming in to
thank you.
To chat with us about this today.
Thank you very much.
Thank you.
And that was our interview with FANUC's Deanstedman. As always, be sure to like and subscribe to Manufacturing Tomorrow's Workforce on your favorite podcasting app and continue the conversation on our Facebook and LinkedIn channels. Thanks for tuning in today and stay safe.